Hello friends, welcome back to your UPSC. So today we'll start with our another topic of geomorphology, that is mountain building. So let's get started. So before studying about theories of mountain building, we should first classify our mountains. So classification of mountain is basically done on the base of three characteristics. First is based on based on geography. So on the basis of geography, we can classify mountains into four types. First is mountain ridges. Mountain ridges are single mountain or single hill having a slope, okay, having a slope and angle of elevation from the plane, okay. So this is mountain ridge. Like we can say, for example, Mount Everest is a mountain ridge, okay. Then is mountain ranges. Mountain ranges are series of mountain ridges, okay. And what is a mountain system? Like Himalayan mountain system, we have like series of mountain ranges. Like this is one mountain range, this is another one, then we have another one, okay. This is mountain system. And now the next and last one is cordillera. Cordillera is a series of parallel mountain laying across one another. It includes valleys as well as ridges. Okay, so ridges as well as valleys. So this whole system is cordillera. So the example of cordillera is Andes in South America. Now next classification is based on the period of origin. So on the period of origin, we have classified mountains into four types again. First is Precambrian era. So the Precambrian era is the oldest era, and Scandinavian mountain and plateau system are the best example for Precambrian era. Okay. Next is Caledonian era. Caledonian era, the example for Caledonian era can be Appalachian mountain, Aravallis, etc. Then is Hyrcanian era. Hyrcanian era lies between Permian and Permo-Carboniferous period. Okay. Permian Permian and Permo Carboniferous period. Okay. So the example of Hyrcanian era are Altai system, Tian Shan system, okay, Altai mountain, Tian Shan, etc. Next is Alpine era. Alpine era is the latest era, which comes in tertiary epoch. Okay, so the most of the mountain in this era are formed due to upliftment of the geosynclines. Okay, so in last lecture we have studied what is geosyncline. So these mountains are formed due to upliftment of geosyncline, and best example for these are Himalayas, Alps, Rockies, Andes, etc. Okay, and the last classification is based on the process of origin. So on the process of origin, we have again four types of mountains. First is fold mountains and complex mountain system. Okay, so fold mountain, we have done folding and faulting in the initial classes. Okay, so we have folded mountain system due to compression. Okay, then we have fault or block mountain. See, do you remember that Horst and Garvin? Okay, so that is the thing which comes in fault and block mountains. Next is volcanic mountains. Volcanic mountain we have studied in last class only, where I told you that the mountains which are formed due to rising up of magma. Okay, and the last one is denuded mountain, or at last they become relic mountain. So what happens in denuded mountain when like the best example for denuded mountain we can see is Aravalli ranges. They are relic mountains. They have rised fully. Okay, and now they are being eroded. Okay, so they are almost like very small hills and something like that. Okay, so these were the classification of mountain. Now we will study about major theories of mountain building. So the major theories of mountain building are two. First is geosyncline orogen theory by Kober, and the next is plate tectonics theory, which is the latest one. Okay, so we have studied geosyncline. What are geosynclines? Geosynclines are the mobile zone of water filled with sediments. Okay, they are mobile zone of water filled with sediments. And so geosyncline orogen theory was given by Kober in his book Der Bauder Erde. Okay, so this question can be directly asked in form of MCQs and all. So this is the name of the book. Now, Kober gave this theory, and this theory is based on the concept that our Earth is cooling down. Okay, our Earth is cooling down, and because it is cooling down, it is contracting, and this contractional force, okay, this contractional force is leading to formation of mountain. And how it is leading to formation of mountain, that we'll see later. Okay, so this is what his theory is based on. Now, there are two terms used in this theory. First is orogen and second is cartogen. Orogens are mobile water zone, that is geosyncline, and cartogens are the rigid masses. Okay, so geosyncline and rigid masses we have done in our previous lectures, in which we studied geosyncline theory. Okay, the whole geosyncline. So mobile zones, that is geosyncline and rigid masses. Around those geosyncline we have rigid masses. Okay, so these are known as cartogens. Now, Kober gave a few cartogens, a few examples of cartogen. They are Canadian Shield, Baltic Shield or Russian Massif, Siberian Shield, Chinese Massif, Peninsular India, African Shield, Brazilian Mass, Australian and Antarctic rigid masses. So these were the cartogen around the. So now his theory is based on these cartogen. Next, next thing which is important in his theory is morphotectonic units. Morphotectonic units are those units or those places which are prone to tectonic movement and where mountain building occurs. Okay, so they are of Mesozoic era. So few morphotectonic units are Africa along with some parts of Atlantic and Indian Ocean. Okay, so this is Africa along with some parts of Atlantic Ocean and Indian Ocean here. So this is a morphotectonic unit, a whole morphotectonic unit. Next is Indian Australian landmass. Second is the another one is Eurasia, then North Pacific continent, then is South Pacific continent, then is South America and Antarctica. Okay, so these were morphotectonic unit, and this whole mountain building has occurred in 6 mountain building periods, out of which 3 are Precambrian period, 2 are Caledonian orogenesis, occurring in Silurian period and Permo-Carboniferous period. Okay, and the last one is occurring in Tertiary epoch, that is the latest one, which is occurring in Alpine orogeny. Okay. So now we will study about the whole process of geosyncline orogen theory. So this is a horizontal contraction movement, we all know. See, this is what I was saying. This is a part of our Earth which is also contracting while cooling down. Okay. So because of its contraction, here we have geosyncline. Okay, geosyncline. So due to this contraction, the matter subsides. Okay. So here we have subsidence of geosyncline and wearing away of mountains. okay, which increase the thickness of geosyncline mass. So geosyncline mass is increasing in thickness because the mountain are wearing away and they are coming inside this geosyncline, and the geosyncline is subsiding as well. We have studied in geosyncline that the depth remains same and this matter, it subsides. Okay, this matter subsides down. So in lithogenesis, this is what is happening. There is a formation of geosyncline basically. And next is orogenesis. We have three phases of mountain building in geosyncline. First is lithogenesis, then is orogenesis, and then is glyptogenesis. We have studied this. Okay, so in lithogenesis, we have this formation of geosyncline basically, and then we have orogenesis, which is the actual stage of mountain building. So what happens in this is, due to contraction, this mass rises up and it starts to fold. Okay, and next is glyptogenesis. Now, what happens in this one is we have this gradually ascending mountains. Okay, the mountain are rising very slowly, and the erosional process is much faster than their rise. Okay, so the mountains are denuding. So here we can say that Aravallis are here, and here we have Himalayas. So these were the basic terms given by Kober. This is foreland, which is a part of rigid mass. Okay, this is marginal ranges between foreland and this geosyncline or median mass. Median mass here is, so this median part is a part of geosyncline. This median part is also known as Wittenberg, and the marginal ranges are also known as Redington. Okay, so this is the whole geosyncline theory, and the examples given by Kober are, first, the best example is Kullan Mountain, then we have Himalayan Mountain, and between them is Tibetan Plateau. Okay. Next is Iranian Mountain between Zagros and Elbrus ranges. Then is Anatolia Plateau between Pontic and Taurus ranges. Okay, and there are many more examples. Now we will move on to the criticism of this theory. So this theory was very important. If we evaluate this theory is very important. It helped in for explaining how the folded mountains were formed. Okay, but it has various drawbacks too. First one is, Kober said that the force of contraction was the reason why the geosyncline is uh, contracting and the folded mountains are formed, but the force of contraction is not sufficient for the mountain building. Okay, of so the mountain building can't just occur because of the force of contraction which is applied due to cooling of earth. Okay, then the second one is, it was actually given by Swiss. The second criticism was given by Swiss, which was uh, later on denied by plate tectonic theory. Okay, so this was actually uh, at that time when the plate tectonic theory was not discovered. Okay, so in this, what Swiss said that in geosyncline only one mass moves. Okay, so the mass which moves is known as backland, which is moving, and the another one is stable. Okay, so the mountains can't be formed on both sides. Okay, but this theory was then cancelled. This criticism was then cancelled by plate tectonic theory, which says that geosyncline, sorry, that masses moves in both side. Okay, and the masses of both side moves, and it is not like that one mass is stable and other mass is moving. Okay, now the next explanation, next criticism is, Kuber explained very nicely the formation of mountain which are running from west to east. Okay, so the mountains like this were explained very nicely, but the mountains which were running from north to south, okay, like Rockies and Andes, their formation was not explained by this theory given by Kuber. So this was the major drawback of this theory. Okay, so the major drawbacks of this theory is first is force of contraction, and second is he was not able to explain the mountain formation which were running from north to south. Okay, now comes into picture is plate tectonic theory, which is the second most important theory of for mountain formation. So plate tectonic theory is basically whole Wilson cycle which we studied in the last lecture. So I didn't told you that that was Wilson cycle. Actually, Wilson cycle is the whole opening up of ocean basin. Okay, I explained you this that these are divergent plate boundaries. Okay, so here what will happen is the magma will rise up and a new crust will form. Okay, and this new crust will form, and with there will be some sedimentations also. Okay, and on the another side, so this is another side, here the mass will be subducting. In the convergent plate boundaries the mass will be subducting, and the plate which is gone inside or subducted, it will melt, and it will again come here. It will go in both sides. Here it will form volcanic mountains. Okay, and here it will again come and form fissure volcanoes. Okay, so this is whole Wilson cycle. This part is Wilson cycle, which explains opening and closing of ocean basins. Okay, so now plate tectonic theory has two things, that is first is divergent plate boundaries or rifting model, and second is convergent plate boundaries. Okay, so in divergent plate boundaries is caused due to tension and stretching. So I explained you how volcanic mountains are formed, and now we will see how divergent plate boundaries are reason for the formation of block mountains. So here we see they are plate. So what happens is there is a tensional force or stretching force which is result which is caused due to internal heat or mechanical forces. Okay, so because of this, these two blocks, they move apart, and because they are moving apart, this part, it subducts. So we can see something like this. So this part, it subducts, and these are the two parts. So this part is forced, and here we have carbon. Okay, so these carbon are block mountains, and the best example of these are Black Forest Mountains. Next we have convergent plate boundaries. Convergent plate boundaries can be of two types. Matlab, the process in convergent plate boundaries can take place in two types. First is subduction, where the heavier plate subsides when we have head-on collision of two plates, the heavier plates subside, and this subduction is mostly heat driven. And the next one is collision is the one which is in which the two plates, they collide with each other and folds occur. Okay, so folds occur. This collision can be formed both due to both heat and mechanical force. Okay, so this was whole plate tectonic theory. We have studied this plate tectonic theory, and we will see this in diagram once again. So what happens is, here we have plate ocean floor, and here we have continental mass. So here what happens is, due to heat and mechanical force, these two plates, they move apart, and here block mountains can be formed or anything. And here what happens is, crack is formed, and due to this crack, the magma, hot magma, it comes out and spreads. Okay, so this is in divergent plate boundaries. And what happens other side, here what happens is, the plate subducts, because oceanic plate is always heavier than the continental plate. Okay, so it subsides, and because of its subsidence, there is rumbling of rocks, and here we can see folded mountains are formed, and here trenches are formed. Okay, and here what happens is, here we have folded mountain, here we have folded mountain, and then here this thing, here was cold lithosphere, but below this lithosphere we have asthenosphere, and asthenosphere is hot. Okay, so here what happens is, so asthenosphere is hot, and because of this what happens is, this plate which has subsided, it melts, and one part moves this side and another part moves this side, because here we have molten liquid filled, and this molten liquid, more molten liquid is formed, and there is no place for it, so it will try to go to another place, or so it moves out. So here it will form volcanic mountains. Okay, and here also it will come again into cycle. So this was the Wilson cycle, and this whole is the plate tectonic theory. So that was all in the plate tectonic theory. So that was all for today, guys. I hope you enjoyed today's lecture. So let's meet in our next class. Till then, take care and have a nice day.